Buongiorno a tutti, sono Giulio Biondi e sarò l'assistente tecnico per questa sessione.
Ok, questi tre. Aspetta, fai cerca. Perché è diverso dal mio?
Perché ho aggiornato, sono cambiate delle cose purtroppo. Vabbè, siamo qua. 2.
Non funziona internet. Mario, io vado nell'altra stanza, se ti serve qualcosa manda un messaggio, ok?
Ok. No, niente, non mi fa entrare né a me né a me. Come si fa? Perché? Io qua sto cercando di capire come funziona. Condiviso. È tutto in portoghese.
Prima vedevamo le vostre slide.
No. Il problema è che è in portoghese è scritto.
E le slide erano quelle da remoto, non da lì.
Ah, ok.
Sai come si condivide? Qua?
E ci ho aperto il PDF.
No, il PowerPoint.
Allora, aspetta, ritorno lì, metti Windows. Questo.
E questi? Ok, vediamo. Però...
Prova ad andare...
Ed è questo? No.
Sì.
Le vediamo questa slide?
Ora se vai avanti.
Ora che vedete?
La vediamo la prima slide della tua presentazione.
Ora
la seconda. Perfetto.
Sì, si sta andando avanti.
Ok, perfetto.
Io ritorno solo con i microfoni, non so se è il vostro.
Come?
C'è un ritorno di microfoni di audio.
Adesso?
Non più.
Ok.
Io direi giusto un minuto e iniziamo perché siamo in tempo. Che dite? Mancano degli speaker che non so se siano presenti lì.
A parte il primo talk è tutto da remoto, quindi...
Esatto. Io ho provato a mandare un messaggio sia alla seconda che all'ultima presentazione.
Ok. Però non ne vedo nessuno. Sì.
No, neanche a me nessuna risposta. Non vorrei si siano confusi con il fuso.
È possibile, ma al limite sarebbero arrivati prima.
Infatti. Nel frattempo aggiungo una cosa in italiano, poi mi switcho in inglese. Saremo in 5 a effettuare la presentazione, perché io, non avendo il dono dell'ubiquità, rimarrò qui e mi farò il quinto, la mia presentazione qui al posto della sessione di Desislava.
Mhm.
Quindi in funzione delle colleghe che si collegheranno man mano, incastrerò anche la mia presentazione.
Ok. Questo per il terzo paper, giusto? Della sessione.
Il paper che verrà presentato, ce ne sarà uno presentato da Antonio Russo, in
Ok.
realtà poi manca il titolo e il paper sull'analisi SWOT, Pestel and Toes, che invece compare nella sessione di Oana di Desislava Petrova.
Good morning. Hello.
Hello Anna.
Hello, Tiziana.
Good morning everyone.
Good morning.
Just few minutes and we will start.
Okay.
Dovete attivare una registrazione o possiamo iniziare?
No, è già tutto pronto per iniziare, viene fatto tutto in automatico.
Ok, perfetto. Good morning, everyone. It's a real pleasure for me to be the chair of this both workshop that connects Solidest and Elliott workshop. It's a pleasure for me to stay here in contact to our colleagues. Today we will have 5 different presentations, and we can start with the first in presence. The authors are Francesco Russo, Maria Luisa Moschella, Giuseppe Musolino, and Domenico Sgro. The speaker is Maria Luisa Moschella, and the title is Model Choice for High-Speed Railway System, the Italian Case Studies. Maria Luisa, the floor is yours.
Thank you. Share. No, ho sbagliato. Così prima. Just a second.
Yeah. Now it's okay.
Okay. Go on.
Yes.
Okay. Good morning to everybody. I am Maria Luisa Moschella, a PhD student from University Mediterraneo Reggio Calabria. The presentation is about the modal choice for high-speed railway system. The motivation behind this research is correlated to the importance of high-speed rail network, the goals of Agenda 2030, and the investigation of travel demand. High-speed rail is considered one of the most important infrastructure solutions to reduce territorial inequality. This is demonstrated by the 70,000 new lines under construction worldwide, in addition to the current 60,000. This important is due to the significant reduction in travel time, which is linked to an increase in accessibility and in the promotion of economic development by connecting industrial area or the city where the high-speed rail is built. However, to produce this benefit, the travel time must be less than 5 hours, in particular less than 3 hours, as shown by an ex-ante study carried out by Giovanni De Brusco in 2030, illustrating the correlation between travel time and user choice. For travel under 3 hours, high-speed rail train is the most competitive option. This social, economic, and also environmental benefit link high-speed rail to the goals of Agenda 2030, both directly and indirectly. But to forecast the impact of a new high-speed rail line is essential to conduct a demand analysis, which means estimating three demand components. The demand diverted from other mode of service to high-speed rail, the induced demand, which estimates the increase in travel frequency on a given origin destination pair, or the change of the final destination, and economic growth demand, which estimate the new trip generated by the economic growth of the territory where the high-speed rail is built. So the general object of the research is the development of a methodology for the study of diverted induced demand, the estimation of these two demand components, and finally assessing the effect of a new high-speed rail line. The activity carried out for this presentation are the illustration of the structure of a database for collecting mobility data on the current situation in Italy, and the illustration of statistical result for travel between the main city of Calabria and Sicily and Rome. The presentation is divided in 4 parts: state-of-the-art, methodology, case study, and future work. The methodological approach used in literature to estimate transport demand involve collecting information on travel behavior of user before the construction of a new infrastructure and the behavior of the user would adopt after the infrastructure is built. To do this, 2 classes of survey are used. Rival Preference Survey, which provide data on travel behavior in actual and thus real context, and Stated Preference Survey, which provide data on travel behavior in a hypothetical scenario, realistic but not real. To collect data about the behavior of the user in the actual situation, we can obtain this data using also nationwide mobility database. This database may include mode of transport, travel time, the number of trips for a given origin destination pair, and also socioeconomic information. These data are useful for the application in transport system model, which are divided in 2 categories. The model that use statistical descriptive approach, which return an aggregate estimation of travel demand, and model that use probabilistic behavior approach for simulate the choice process of individual user, which return a disaggregate estimation of travel demand. As I said before, the high-speed rail demand is divided in 3 components: divert, induced, and economic growth. The first 2 components have impact in the short, medium term. The third one has impact in the long term because as a result of structural change in the territory where the high-speed rail line is introduced. So with the first 2, we analyze the direct impact in travel demand. With the third one, we analyze the indirect ones. For this reason, we choose to analyze the first 2 demand component because the diverted demand permit us to analyze the competition of the high-speed rail with other modes, in particular with the air mode. Induced demand because permit to analyze the increase in travel demand. The diverted demand is analyzed with mode service model, while induced demand is analyzed with destination frequency model. Whilst diverted demand has been largely studied in literature, there are gaps in the research on induced demand, both in terms of methodology and calibrated parameters. The review of the current state of the art carried out using Prisma method and snowball technique revealed that induced demand had also been investigated using other types of model in addition to the frequency and destination model shown before. We have classified this model as before and after model, implicit model, and overnamed model. In this model, induced demand is not separated from the other two components, diverted and economic growth. This slide shows the flowchart classifying the model and the method developed by the authors. We can see that of this work, only 10 articles fall into the category of generation distribution model. However, in this work, there is a lack regarding the description of the methodology used to obtain the induced demand. The methodology developed for the study of high-speed rail demand involved the data collection as a first step. In particular, rival preference data and as the data about the behavior of the user in the actual situation collected using the Vodafone Business Analytics Service, which gathered telephone data, and through a survey conducted using a questionnaire given to a sample of user. The survey is divided into main sections. The first belongs to the rival preference survey and gathered information on user travel preference to Rome from the southern Italy and the current operating condition. The second section belongs to the stated preference surveys, which present a scenario of a new high-speed rail line, including travel time and fare scenario. The Vodafone database feature concern three modes of transport: air, train, and bus, a minimum travel distance of 100 km, the aggregate number of travel for each origin destination pair under study, and the classification of the passenger. In particular, the total number of travel is given by the sum of the travel with the same combination of attributes. This attribute can be maybe spatial or temporal. So the travel were aggregated only if sharing common attributes such as the same origin destination, the same day of the week, the same time slot for the departure and arrival, the same class of passenger. Finally, we get the total number of travel for each combination of attributes. And this slide shows that the database comprises several nodes. The origin and destination investigated in particular have been broken down into region, province, and municipality for the Calabrian Sicily region, and region, municipality district, and municipality for Lazio, Lombardy, and Campania. Specifications were also made in terms of time, such as the day of the week and the departure and the arrival times, and the observation period that is 35 days from March and April 2025, which is broken down in the period before Easter and the Easter period. As can be seen, the database is structured into columns. These columns correspond to the attributes shown before. So filtering permits the selection of the spatial and temporal attribute of interest. From first analysis carried out on the Vodafone database, the study focused on travel between airport and railway station located in Calabria and Sicily, with the airport and railway station located in Rome. The Calabrian city included Reggio Calabria and Lamezia Terme. The Sicilian city included Messina, Catania, and Palermo. As an example, this slide shows the graph relating the travel from the city, the airport, the railway station of Reggio Calabria and Lamezia with the airport railway station of Roma. The data analysis provide so the current modal split for travel between the main city of Calabria and Sicily and Rome in both directions. And the analysis reveals a clear polarization in transport choice with the air travel dominating for travel from Sicily. In fact, as the distance between a city and Rome increase, air travel become the primary mode of travel. The aim of supplementing mobility data extracted from this type of database is to tailor the sample of user investigated and thus the data obtained from the survey. This is important because sample survey does not reflect the actual distribution of choice within the entire population. So the first step is the data extraction from the Vodafone mobility database, selecting the spatial and temporal attribute. In this case, the period right before Easter was considered, and as origin-destination pair, the province of Reggio Calabria and Catanzaro for Calabrian region and Lazio region were used. The resulting flow of air and trains between the origin-destination pair provide the estimation of the modal share for the population, for the entire population. The user preference revealed by the survey provide the estimation of the modal share of the sample. These two factors determine the correction to be applied to endogenous biases in order to obtain consistent estimation the modal split in order and finally apply the transport system model. So this work permits the development of a nationwide mobility dataset based on aggregated data covering 35-day period, including 10 airports, 21 railway stations, and 19 bus hubs in Italy. With this data, we carry out initial analysis in the current of the current TMAT, in particular the modal split for the section of several cities of Calabria and Sicily to Rome and back. Another result was the estimation of the bias correction for the sample of respondents in order to obtain consistent estimation of the modal split between the Italian region of Calabria and Lazio. The future step is the application transport system model to estimate the diverted and induced demand. Thank you.
Thank you, Maria Luisa, for sharing your research. Are there some questions? No, not yet, I think.
Okay.
We can continue with our second presentation. The authors are Oana Dinu, Eugen Rosca, Ilona Costea, Andrea Alonso Ramos, Aura Rusca, Anna Maria Ilie, and Christian Marin. The title is Decarbonizing Long-Distance Transport, Modal Shift from Short-Haul Aviation to High-Speed Rail for Sustainable Mobility. Oana, the floor is yours.
Hello, everybody. I don't know if I shared my screen. Can you see my screen?
Yeah, but put
okay,
in,
so if I do like this, it will be the whole screen?
Yeah, now it's correct.
Now it's better. Okay. So first of all, my name is Oana Dinu, but I want to congratulate my my colleague that presented the paper before. It's very interesting. It connects a little bit with our study, but it's more into it. So I think that I can use their work to further develop ours.
Thank you.
I'm sorry that I couldn't be there. I had an event in my family, so I had to stay home, but I hope to see you maybe next year. So my name is Oana Dinu. Our paper, Tiziana already presented the name. We are, most of us, we are from National University of Science and Technology Polytechnica in Bucharest. And we also work with Andrea Alonso Ramos, which is from Polytechnic University of Madrid. In this presentation, I will discuss whether some domestic short-haul flights in Romania could realistically be shifted to rail, and what this could mean for sustainable mobility and decarbonization, especially in this context of war, of high price of oil products, and we all see what's the result on air market. To begin with, long distance transport generates significant emissions, and it's clear that aviation is under increasing pressure to decarbonize. In general, research shows that on distance of around 300 to 700 kilometers, rail can become a realistic alternative to short-haul air services, especially when infrastructure and service quality are strong enough. So, our main goal for this paper was to evaluate the potential for air-to-rail modal shift in Romania, mainly by analyzing transport infrastructure network, the connectivity structure, and the linking it with traffic data, and with possible CO2 savings on key domestic routes. Romania is not such a happy case. The main problem is that in Romania, rail is not yet a strong substitute for travel, for domestic air travel. We have infrastructure gaps, reduced speed, reduced capacity, reduced efficiency. And this is one of the main reasons why aviation remains dominant on several domestic relations. The double track share is quite low, it's below 30%. The electrified truck share is below 40%. And more than this, passenger rail activity fell by around 50% between 2060 to 2025, mainly because of poor management of the national rail company and poor services. So this is clear why limits on modal shift potential are present. We begin by presenting the study areas. First, in the aviation network context. To begin with, Romania has 17 operational airports, but the airport system is strongly concentrating around the Bucharest Henri Coandă Airport, which is coded OTP, is also the main national hub. We analyze the data, and OTP handles more than 60% of the national passenger traffic. So it's clear that any discussion about domestic modal shift must take into account this strong concentration of the air connectivity. The next in importance airports are Cluj Airport, coded CLG, Timișoara, and Iași probably. Okay. In this slide, we move to the railway network context. Romania rail system still has major structural limitation, mostly because of the low share of double track and electrified lines. At the same time, we highlight an important long-term opportunity. We have a planned high-speed rail corridor connecting Constanța, which is the main port of Black Sea, to Hungarian border. In the image, you can see this corridor drawn in purple. It's around a little bit less than 800 kilometers. And this could become the backbone for more competitive rail services in the future. About methodology, the analysis that we followed has 6 main steps. So we made the air network assessment, air network assessment, rail network assessment. We did the traffic data collection. We followed by connectivity analysis using formulas that I will present you after. We built a modal shift scenario, and finally we estimated the potential savings of CO2. So in this way, our study combines infrastructure, transport infrastructure analysis, connectivity metrics, and with scenario-based environmental evaluation. We did evaluation on the Romanian wild scale. Regarding air connectivity assessment, we assess the structure of air connectivity, and for this we use connectivity index to evaluate how airports connect passengers to destination through both direct and indirect links. So the direct links reflect non-stop accessibility, while indirect links capture hub-based connections. So higher indirect connectivity may suggest stronger potential for substitution, but only if rail becomes more competitive on domestic feeder type route. And in the formula, you can see how we calculated the air connectivity index. Year-over-year dynamics across the main airports in Romania are presented in this table. So one key observation is that indirect connectivity plays an important role in the Romanian system, especially for larger hubs such as OTP, so Bucharest Airport, and CRG, which is the second biggest city in Romania, Cluj, located in Transylvania, in the west part of the country. Why this matters? This matters because a better rail offer could reduce dependence on some indirect or feeder air movements and support stronger air and rail intermodality. Once the connectivity was assessed, we moved forward to the modal shift scenarios. So we tested 3 scenarios, 10%, 20%, and 30% shift from air to rail. And we applied them to 3 key main hub OTP Bucharest Airport linked domestic routes. So the route between Bucharest and Cluj, the route between Bucharest and Timișoara, and the route between Bucharest and Sibiu. These scenarios assume that the high-speed rail corridor is operational. The train runs at around 250 kilometers per hour, and the rail travel time becomes competitive enough to attract part of the current air demand. The detailed numerical scenario table and the results are presented in this slide. Across the selected routes, the analysis considers a total domestic demand of 1.2 million passengers per year. And under the three scenarios, the shifted traffic reaches 0.12, 0.24, and 0.36 million passengers for each of the scenario. In parallel, the corresponding CO2 savings are estimated, with the largest contribution clearly concentrated on the OTP, so Bucharest-Cluj relation. This slide summarizes the key findings. The main message is that the scenarios produce measurable environmental benefits, but these benefits still remain moderate at national scale under the present conditions. Of course, the highest gains appear in the 30% shift scenario, while roughly half of the total savings come from the Cluj-Bucharest relation, showing that the effect is quite concentrated geographically. When discussing limitation and further work, we acknowledge the main limitation of the studies, and this is that the analysis relies on aggregated traffic data for the last 2 years, 2024 and 2025. In Romania, we have big difficulty with data gathering and databases in this transport and transport related field. So we had no granular route level domestic data set. So the domestic demand had to be estimated, and the CO2 calculation used simplified assumptions. So for future work, is clear that it will be important to include real life delays, so real life data, ticket cost, road completion, fare integration, behavioral factors, sensitivity analysis, and all of this in order to produce a more robust, a more realistic picture of this modal choice for Romania. Of course, that this shift from air to rail has policy implication. So our paper had to had some policy relevance. Our results suggest the need to prioritize rail upgrades on strategic corridors. It has been it's in progress now, but it's quite slow. To strengthen airport rail multimodal hubs and to align infrastructure investment with priorities and EU Fit 55 targets. So, in other words, this paper is not only on an academic exercise, it contributes to the broader debate on sustaining this high-speed corridor. So, to conclude, our main message is that air-to-rail model shift in Romania is promising, but it's not yet fully supported by current infrastructure. It's clear that the railway system still needs substantial modernization before it can become a strong substitute for domestic short-haul aviation. And At the same time, better infrastructure, stronger multimodal integration, and continued policy support would gradually improve this picture and support long-term decarbonization of long-distance transport in Romania. Thank you very much for your attention.
Thank you, Anna, for your presentation. Are there any questions? Yes, Giuseppe?
Yes, thank you for your presentation. No, I understand that you're working to develop the modal choice model as a future step.
Yes.
To better estimate the modal shift. Just a question today, now.
Yes.
What is how you the modal percentages or exogenous, or they seems to be in relation with the connectivity index? It is not.
No, I used.
I ask if you could add some clarification about this passage from connectivity index to modal share.
No, we just try to use this connectivity index to show us if there is some potential shift from rail to air to rail.
With the
Just
qualitative consideration, just
yes, just for this, because for real this high speed rail is just let's see an idea, so it's not on the paper right now. It's just an idea, and we just try to see if it could work on the basic level first. Just started. It's not a project. We are not working on this project.
Yes,
So
yes,
it was
it's
just
a scenario. You
an
simulate a
incipient idea
scenario.
to see if we can support in some way this. We have this big problem that there is no data that we can use. So it's only aggregated data, and it's quite difficult to work with it. We have problems with the rail company, which is not helping at all. So
If I can, there is a consolidated literature
yes,
about aggregated estimations with the before and after studies.
yes.
I think you can compare your first assumption with what is present in the scientific literature.
Okay, I will.
As
Thank you.
further step. Thank you. Thank
There
you.
is another question, Professor Russo.
Non si sente proprio.
The microphone is switched off. No,
No,
we
not-
cannot hear you.
We cannot hear you.
Sorry?
We cannot hear you.
And now
Yes.
it's okay?
Yeah.
But just a short question. The actual modification to modify from actual situation to the design situation, 10%, 20%, and 50%. If I don't understand bad, is generalized on all the airport and on the all railway line. Is correct?
Yes, it is.
But you
No,
consider
we only chosen 3 main routes, not on all the network. Only 3 main links.
airline links on or railway links.
They have correspondence both on air and on rail.
Okay, but the railway link that you consider is the line inserted on the European network.
Yes.
Is the problem.
Yes.
Because in the plan that you present in the first slide is not clear what line is on the European network.
It's on the
what
European
line?
network. It's on the 10T corridor.
Okay.
Yes. So
And then you modify just on this corridor.
yeah, I just not to layer it on the corridor, just to see where it passes. So it's on the 10T corridor.
Okay. Thanks.
You're welcome.
Okay, any other question? Not yet. We can continue with the third presentation. The authors are Antonio Russo, myself, and Giovanni Tesoriera. The title is Assessing the Potential of Demand Responsive Transit for Not Emergency Healthcare Travel, an Accessibility-Based Approach. I invite Antonio Russo to share the screen.
Are you seeing my presentation?
No, okay, now it's okay.
Are you seeing the slides moving?
Yeah.
Okay, thank you. So, hello everyone, I'm Antonio Russo of the University of Bernacore. Thank you, Professor Campisi, for the presentation. Our work focus on a pilot study to understanding a general framework for use open data available for the study of public transport coverage for hospital for healthcare facility access. In general terms, the focus of this work is at the intersection of two areas of United Nations Agenda 2030, which is the goal-free good health and well-being, that especially in the target 3.8 express achieve universal health coverage, including financial risk protection, access to quality essential healthcare service, and access to safe, effective, quality, and affordable essential medicines and vaccines for all. In which, in this target, United Nations formalize the presence, the importance of accessibility to service in a broader terms, which include also the physical accessibility, the transportation accessibility, the activity system accessibility to healthcare structure. So transport dimension is a component of healthcare service accessibility, and in this sense, the other dimensions involved is expressed by the SDG 11, Sustainable Cities and Communities, in which target 11.1 identifies the need to provide access to basic services for everyone. So in this context, it is important to understand that obviously healthcare mobility comprises a share of mobility which is not related to emergency trips, but can be planned and involve specific user with specific accessibility or mobility needs, older adults, people with disability, or patient with chronic condition. In this case, we wanted to understand if for someone who may face barriers to use private care, private transportation, or who cannot drive independently, which are the possibility to implement to use public transportation to reach hospital and healthcare facilities. Possibilities are offered maybe by on-demand transport services. An analysis of the literature on these topics focus an high heterogeneity of methods and methodologies implemented, and also a focus on large urban areas with huge demand, huge residential population, and a good coverage of healthcare facilities on the territory. So our general framework tries to understand hospital accessibility based on use of open database, and also the focusing on a rural area with the presence of small and medium-sized urban centers and large areas with low population density, but in absolute value, a huge number of residential people. So, about methodology, we want to understand the several sets, the zone in which is divided the study area, each of them characterized obviously by a population and a demand component like population and the surface, the set of healthcare facilities, the set of existing public transport lines, and the set of public transport stops. The objective is to understand the coverage of public transport which allow the access to hospitals from each side of the city, of the urban area, and to understand if there are gaps that can be possible covered by on-demand services like the semi-rigid demand responsive transport services. Also, we have to understand several criteria for defining at the end the set of stops which serves the hospital structure H studied. For the final terms is for each zone to understand which is the percentage of population covered by a specific ISO distance from the generic stop of the set S star, and the population covered in absolute value and in percentage for each zone. So, which is the point? The point of this work, the general framework is divided into these two areas. The data acquisition is based mainly on three components. One component related to the main component of demand. In this case, population is the most generic variable that can be used, and is public available. For example, for Italy, the ISTAT database disaggregate the demand at the level of the single census zone. The supply system, for example, the bus lines of several companies are directly, both bus lines and bus stops are directly available from OpenStreetMap, and the distribution of sanitary services. This is a part of the demand side of the activity service, the supply side of the activity service. All of them are open access data, and the data analysis through the methodology previously seen conduct to the study of the indicators and the missing gaps in terms of both population covered in absolute value and in percentage for each zone. So we applied the study to this methodology to a case study in Central Sicily, the municipality of Enna. The municipality of Enna has several characteristics that make it somehow very particular, which are the main urban area that is very high on the level of the sea, approximately 1,000 meters, and is in very distant from the sea. Also, it is in an area which is loosely populated. This is the map of the municipality of Enna, considering the population density for each census zone. Only 3 zones of the municipality show consist relevant urban settlements, which are the area of Enna Alta, which is the historic center. Enna Bassa is the new area corresponding to the expansion area, and Pergusa is an outskirts which is connected to several tourist related activities in the south part of the municipality. But the larger part of the municipality is do not show continuous urban settlements. So the population density is concentrated mainly in the central part of Enna, in Enna Alta and in Enna Bassa, as you can see in the zoom in the right picture. There are 8 public transportation lines and only one hospital, so we can define both the set of transportation lines and hospitals. The hospitals is placed in Enna Bassa, in the new expansion area. The lines connect well all the main urban areas, but only in certain part. This is the 300 meters ISO distance evaluate, pedestrian auto distance evaluate for the transportation stops, and essentially the area mainly covered is the northern part of the city. This is the results in terms of percentage of population. As you can see, in general terms, for the area of Benna Alta, so the historic center, the area is served by 4 lines that connects more or less all the neighborhoods of Benna Alta to the hospital. So aside of a few zones in the central part and southern part of the city, the coverage in terms of percentage is higher of 50% for more or less all the census area, excluding some of them. The yellow one are census area with no population covered. And regarding Enna Bassa, on the other side, the conditions is less homogeneous because, for example, as you can see, there are an entire neighborhoods. The most recent one just near the Department of Engineering, which is in this area, which is loosely covered with the hospitals that is on the other side of the expansion area. So in this case, for example, in the case of Benna Alta, okay, maybe population, maybe we cannot consider with the urgency the introduction of the possible on-demand system because it is well covered from a spatial perspective, is well covered by existing public transport services. And also for Enna Bus, there are several neighborhoods that can gain something from the introduction of an on-demand service. Finally, the area of Pergusa. The area of Pergusa has a very low population, and also the coverage is less significant compared to the previous 2 areas. Also, let's consider that this outskirts is distant approximately 10 kilometers from the main city center, which is a huge distance from vulnerable population groups. So in this case, an on-demand system, consider all of these aspects, may be taken into considerations. In general terms, the other problems, the significant problems is connected to the exploration of the study to area which are outside the main urban center, which is the main point in which where the traditional public transport lines are usually placed. So the free area and Alta, Bassa and Pergusa are covered in different way by existing public transport, while there are entire part of the city which are essentially of the municipality, which are essentially urban rural areas, which are loosely populated, but in terms of density, but some of them show an high values in absolute value of population. And in this case, open database like ISTAT, the Italian statistical entity for census and aggregate statistics, show no more disaggregation possible in terms of distribution of population. So more in-depth demand analysis has to be done for all of this done, which be the most interested for the introduction of potential on-demand services. Consider also that proposed analysis is a preliminary assessment, which also requests several improvements in terms of which will be included in future studies, which include the possibility to introduce also temporal accessibility to hospital structures, and in general terms may be considered also other demand variables, like, for example, more disaggregation based on age or gender. So thank you for the attention.
Thank you, Antonio, for your presentation. Are there any questions? Not yet. We can continue with the fourth presentation. The authors are Mirna Klobukar, Alexandra De Luca Tibliash, Sania Shurdonia, and Irena Istoka-Optovich. The title is Traffic Flow Analysis of Closely Spaced Roundabouts and Signalized Intersection. And I invite Mirna to share the research. Mirna, the floor is yours. The microphone, please.
I'm sorry.
Don't worry.
Just a second. Good day to everyone. My name is Mirna Klobuchar from University of Rijeka, and today I will present our case study on traffic flow analysis of closely spaced roundabouts and signalized intersections. Roundabouts are being increasingly integrated into urban traffic networks as new intersection as a part of reconstruction. They have many advantages. They can reduce delay, travel time, and with the geometry, they act as a traffic calming measure. But when placing in the cities, placing a roundabout in a signalized corridor can cause their mutual negative interactions. A roundabout and signalized intersection operate under very different traffic control regimes. Previous research highlights two main problems. First is acute spillback from the signalized intersection into the roundabout that can cause complete traffic blockage. And the second one is vehicle platooning from the signalized intersection, which changes the vehicle arrival pattern at the roundabout. Guidelines worldwide mainly address roundabouts as isolated intersections. Mixed corridors are simply not recommended in the most of the technical regulations. Only American and Australian guidelines suggest, in the case of mixed corridor segmentation into the subsystems or partial roundabout signalization. Spacing criteria between roundabouts and signalized intersection is mainly descriptive and qualitative, and only American guidelines make a distance of 500 feet or 152 meters as a minimal distance between the roundabout and signalized intersection. This case study focuses on the city of Poreč, which is a city on the west coast of Croatia. Case study analyzes the traffic segment that consists of one roundabout and one signalized intersection in mainly residential area nearby a historic city center and main parking facilities. The distance between the roundabout and signalized intersection is 125 meters, with outer radius of the roundabout 18 meters and a cycle length of 70 seconds. First step was to collect field data, traffic volume, structure, traffic distribution, and vehicle speed. It was collected with automatic traffic counters as well as travel time. Field data showed almost 14,000 vehicles per day at the roundabout, with 991 vehicles per hour in afternoon peak hour, which sums to 7.1% of share of daily traffic. Based on the field data, a VISIM model, microsimulation model, was developed in VISIM. And the model was calibrated based on the travel time on a route of 300 meters from the roundabout to signalized intersection. Travel time was collected by 10 vehicle passes by 3 different drivers. And relative deviation between the measure and model travel time was 1.71%. Just for comparison, relative deviation without calibration was more than 15%. calibration was done by adjusting a driver's parameter of Wiedemann 74 model, average standstill distance, additive part of desired safety distance, and multiplicative part of desired safety distance, as well as random seed increment. For development of the analysis, another different scenarios were developed summing four different scenarios. First was existing configuration with existing traffic demand. Second was existing configuration with 20,000 vehicles per day as maximum recommended capacity of the roundabout according to Croatian guidelines. So this is scenario 1 and 2. Third scenario was eliminating an influence of signalized intersection with existing vehicle traffic demand. And the fourth scenario was isolated roundabout with the maximum recommended traffic demand of 20,000 vehicles per day. Results show that isolated roundabout with existing traffic volume shows better traffic indicators, 19% lower vehicle delay, 28% lower stop delay, 10% lower travel time, and also level of service was improved from C to B, indicating that signalized intersection in a short distance from roundabout significantly influences roundabout performance. But with higher traffic demand of 20,000 vehicles per day, isolated roundabout shows slightly better results, but both configurations showed level of service F. And this is a comparison of all the four scenarios. So for the conclusion, most guidelines still treat roundabouts mainly as isolated intersection. This case study shows that the short distance between roundabout and signalized intersection can significantly degrade corridor performance. So when placing a roundabout in a signalized corridor scale evaluation is very important, especially under higher traffic volume. Traffic volume showed to be the dominant factor in analyzing roundabout performance, which is consistent with many previous research, but also peak hour volume also shown to be very significant. So for the future research, the plan is to extend the tested geometric and control conditions and also traffic demands with different scenarios, and also extend the research to include pedestrians' impact and also the cyclists' impact. This is a list of published papers. This research is part of a broader doctoral research. And a part of project Next Generation European Union. Thank you.
Thank you, Mirna, for sharing your research. Are there any questions? Not yet. Now I will try to present my final presentation, and I ask the Maria Luisa to switch off their the microphone, because we'll listen something made by the Okay, I just trying to share my screen. Just a few seconds. Can you see my screen?
Yes.
Okay, we see a screen.
Okay, great. Our research is titled Strategic Planning of Integrate Public Transport and Demand-Responsive Transport System through PESTEL, SWOT, and TOWS analysis, the case studies of ENNA. The research was made by myself, Chiara Spadaro, Antonio Russo, Guillermina Torrao, and Giovanni Tesoliara. Today, I'm pleased to present our research using a sequential methodology that combines pastels, WOTS, and TOES analysis. And we examined the specific case of studies of Enna, a city in the southern part of Italy, barycentrical, located in Sicily. Our main goal is to demonstrate how data-driven, evidence-based strategic planning can transform mobility in challenging urban and peri-urban environments. We can begin the core context of these studies. In fact, today, the public transport planning face critical challenges addressing the needs of peri-urban and island areas. These regions are typically characterized by low demand density, complex topography, and social territorial fragility. And the traditional fixed route transit is often inefficient here. Here we can summarize some of the main benefits and challenges that can be made by the integration of the traditional fixed service made by bus with the flexible strategies of demand-responsive transit. And our goal, just like described, is to investigate a context in order to obtain, in case of a test pilots, similar condition or strategies that could be applied in our low demand areas that demonstrate and describe a big percentage of our Sicilian context. We introduce, in fact, three different steps, three different approach that are including and demonstrate the feasibility of a potential introduction of both services, combined services. The first is considered PESTEL, that analyze the external macro-environmental factors in terms of the acronym political, economical, social, technological, environmental, and legal factor. After that, we identified by SWOT analysis the internal strengths, weakness, and the external opportunities and threats. And finally, we combine the theoretical approach to active approach, including the tools, including some factors that can generate active data-driven strategic choice. To test our framework, we select our cities, the city of Enna in Sicily, that highly representative of Italy inland areas. It features significant topographical variation with a historical city center located on the peak of the mountain, separate from the modern valley expansion titled Enna Bassa. These discontinuous settlement patterns create inequalities in accessibility. Currently, the cities relies on fixed route buses that suffer from low load factor and high deficit. It is a perfect laboratory, Enna, in order to evaluate how a hybrid service of bus and DRT can bridge these geographical and social gaps. Our first analytical step is the PESTEL analysis that evaluates the external macro environments. Politically and economically, we are driven by European Green Deal compliance and the national recovery funds like recovery plan, balanced against the needs to optimize local public expenditure. Socially, there is a strong dependence of private vehicle, private car, alongside vital needs to provide accessibility for university students and aging population. Technological modern intelligence, artificial intelligence driven routing apps make probably DRT viable today. And finally, environmentally, we must reduce emission, while illegally we must navigate strict public procurement and GDPR regulation. Moving to the internal analysis through the SWOT framework, we can observe separately on the next slide something in terms of relative factor and relevance. In terms of strength, the city already has a baseline transit infrastructures and very clean, practicable high-demand corridors, specifically the route that can connect Enalta with Enna Bassa and the university campus. Awareness in terms of weakness, we can observe that the current fixed route lines suffer from the high operational deficits and during the off-peak hours especially, and there is a total lack of a digital integration or user-friendly smart ticketing. Here we observe similarly some opportunities that can combine our previously means in terms of opportunities related to the integration of both services, and some threats that can obstacle the application of the combined services. After that, we observe and we continue our studies with those matrix that can include the first of our offensive turnaround strategies. We can observe something in terms of connection of strengths and opportunities, and we propose maximize external funds in order to launch a smartphone managed DRT system, target directly at university corridor, firstly, during the peak students hour. In terms of weak and opportunities strategies, we aim to minimize our internal weakness by replacing the most inefficient, low demand fixed line with flexible DRT services, and could eliminate deficits through digital fleet optimization. In this other slide, we combine something in terms of strengths and threat strategies, and we can counter the threats of private car dependence that can determine some obstacle in terms of flexibility, reliability, and something also in terms of cost saving of a personalized DRT system. And finally, in terms of weakness and threat strategies, in which we want to minimize both internal weakness and external threats, and we propose designing a hybrid booking system. This includes traditional phone booking and also mobile app in order to encourage especially the big percentage of elderly people that live there in order to use this type of services. Before we look at the specific impact of our stakeholder, let us synthesize the key results of our 3 steps analytical process. First, in terms of macro environmental insight, we confirm that a traditional fixed network is no longer sustainable under current European Green Deal and founding guidelines. The demographic reality of Enna demands a flexible approach and not a static approach made by boss. Secondly, we identify the powerful operational synergy by feeding dynamic DRT lines into high-frequency corridors. We can probably eliminate empty run and optimize fleet using the low demands hour. And finally, the strategic output on this research, that is a resilient, scalable mobility blueprints, specifically made designed for complex high-altitude inland areas. And this brings us directly to how these strategic results can translate into practical values for our key stakeholder. The results of this three-step analytical process, that is the basis for the real plan and the test pilot services process, can define clear benefits for three different category of stakeholder. In fact, for service operator, it provides operational guidelines to optimize fleets and improve economical efficiency. For local authorities, it offers a structural baseline to allocate public resource effectively and design integrate mobility policy. And last but not least, for citizens, that can translate into a shorter waiting time, greater territorial equity, and much better to access to essential services. In conclusion, integrated local public transport with DRT is not just strategically viable, but economically and socially necessary for our case studies. And this research contributes a scalable resilience blueprint for island territory. And during the next step, we recommend launch a 6-month pilot project in our specific low-density districts to gather empirical data, followed by standardized data collection to fully refine our automated routing algorithms. Thank you for your attention. I underline that this research was supported by Smarter Fleets project. There are any questions? Is there? Not yet. I want to thanks again to author, and the speaker that share its presentation. It was a pleasure, and I hope that you stay here for the next activities. Good morning and goodbye to everyone. Bye.
Goodbye.
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 Bye. And thanks.